It's a great pleasure to be allowed to introduce Professor Lewontin. He's an old friend and my former postdoctoral supervisor from my time at the University of Chicago. Professor Lewontin, as you heard yesterday, Professor Lewontin received his undergraduate degree from Harvard and then a master's and PhD from Columbia University, where he was a student with Theodosius Dobzhansky. He then held faculty positions at North Carolina State University, University of Rochester, and then the University of Chicago before moving to Harvard to become Alexander Agassiz Professor of Zoology. In addition to the great many honors that were mentioned yesterday, Professor Lewontin was elected to the National Academy of Science in 1967 and then resigned the National Academy in 1973. Now, Dick Lewontin has really had two careers. One career as an evolutionary geneticist and another as a public spokesman for science. As an evolutionary geneticist, he's made major contributions to both the theory of evolutionary genetics and to its experimental study. He was among the first to use computers as tools for simulation. He was among the first to use the tools of modern molecular biology to study genetic variation in natural populations. In 1974, he wrote a book entitled The Genetic Basis of Evolutionary Change, which really defined the research program in evolutionary genetics ever since. As a public spokesman for science, he has entered, I think, every major controversy involving genetics and evolution. If he hasn't, it was only an oversight. As a result, he entered the controversy over sociobiology, over the use of genetically modified organisms, over race and IQ, over large-scale genomic projects, and many other controversies. In these areas, he has always been provocative, controversial, and stubborn. And it's a great pleasure today to introduce him to speak on one of these topics. His title is The Concept of Race, the Confusion of Social and Biological Reality. Dick?
Thanks very much, Monty. I only want to make one correction to your introduction, and that is the notion that I ever supervised you is a very extraordinary one. We were together for a while, but I certainly never supervised him. The lecture today is rather different from the one I gave yesterday. The one I gave yesterday was largely impressionistic, if you like, and heuristic. Today I'm going to bombard you with numbers. I'm sorry about that. Those of you who hate numbers, perhaps you should leave now. But the subject of race as a biological concept cannot be dealt with except numerically, quantitatively, that is to say, and the best way I know to do it is with numbers. So I should warn you about that it may in some ways be a disappointment to you, and I regret that, but I don't know how else to do it with intellectual honesty. The question of race is a curious one. The classification and denomination of others as belonging to different races is, of course, not a uniquely American nor European phenomenon. The Japanese have their notions about race. Indeed, the word race has had many meanings. We speak, for example, of someone being the last of his race, and what we mean is the last member of his family. Or the human race at the other extreme, which means the entire species. So that race, which comes from the root, means what that person sprang from. And the notion that we understand who we are and others belong to a different kind, a different race, seems to be, if not universal, because I don't know enough about what everybody in the world or every culture thinks, seems to be extraordinarily widespread. And I've tried to understand that and I think we should all try to begin with to ask ourselves, why is it that the concept of race, the division of the world between us and them, whoever us happens to be and them happens to be, why that is so common historically and culturally and geographically? I would like to make a couple of suggestions. They're only suggestions. One is, of course, that one is constantly, certainly in the history of the human species, and in the early history of the human species, but still true, there is a kind of, if I may call it, nationalism or localism or villagism or tribalism, or whatever you want to call it. That is to say, a group that has solidarity living together, which deals with other groups that have their own solidarity, often in a hostile and contradictory way. And so there's a constant reiteration of the within our group as opposed to as against those. And that occurs at the village level in people in the Amazon. It occurs at the national level in Europe and everything in between. So that constant struggle between the group of which you are a member and which you have some economic, social, marital, other kinds of religious ties as against somebody else already creates a separation between them and us. That seems obvious. But the other thing, which is perhaps not quite so obvious, is that the concept that there exist other races comes in great part from our perception of the variation among people in the world and the variation that we know among those people with whom we were brought up. To illustrate that, I'll tell a story which my wife will tell me is not quite accurate, but it's what we call vraisemblable. I mean, it's close enough. She and I were in Egypt, Upper Egypt, years and years ago, and we were in a large hotel, and a man came up to her and started to talk to her volubly about something, an Egyptian. And she kept saying, no, you've got the wrong person. I mean, I'm sorry, I really don't know what you're talking about. I don't know what this incident is. And he kept at it and kept at it. And she kept insisting that, no, he'd made a mistake. And finally he stepped back and said, oh, I'm terribly sorry, but you all look alike to me. And this notion that you all look alike, but we all look different, is a consequence of our acculturation, our walking down the street, our understanding of who is whom. I mean, again, to make it personal, my wife and I often play a game. We walk down the street in Cambridge, which is a very cosmopolitan community, unlike Berkeley, of course. And we walk behind people, and I put my elbow there and I say, French. And she'll say, German. And then we walk a little faster in order to catch up with them to hear what they're saying. And one of us is right, usually, or the other. That is to say, the very motions of their bodies, the way in which they move their faces and lips and hands, their total physical appearance tells us that they are not Americans, and even gives us hints about what they are. My greatest triumph in this respect, which I'm very proud of, is that once we were in the desert in California, and on the top of a knoll, very far away, I mean twice as far as the back of this room, was a group of young people who were talking to each other volubly. You couldn't hear a syllable that they were saying. And I said, they are French, and I was right. So you must take account of the fact that there are local differences in every aspect of culture, including body appearance and carriage and so on, of which we are not ordinarily conscious until we confront people who come from someplace else. And the result of that has been that you all look different, but they all look alike. And that is a consequence of that acculturation. Now the question I want to talk about today is really, what is it we know in some objective sense about the variation among human beings that corresponds or does not correspond to that perception that we all look different and we recognize each other instantly, but they all look alike. I mean, what can we say about that? Because, of course, it has immense political consequences. Once you agree that we are all different, but they are all alike, you also have a way of handling the problem of colonializing them, enslaving them, dealing with them in all kinds of demeaning and power and ways of asymmetric power, because they're all alike anyway. And that, in a sense, dehumanizes them. But part of that dehumanizing process is not that they don't look like us, but they are all alike. They can be objectified. They belong to a race, and once I know that, I know all about them. That's all I need to know. Whereas, of course, if I say they're Europeans or Americans or something, then that doesn't help me much, because, after all, we're all different. So the reason this talk will be so numerical is precisely because we need to ask the question, how variable are human beings within groups and between groups, within those people who speak Swedish as opposed to those who are Kikuyu or whatever? How much objective reality is there to the claim that I just discussed about differences within and between groups? And of course, to say objective means obviously to ask about genes, because nothing else is objective. So, well, I have to apologize for that, because the last lecture downplayed the importance of genes. But genes have one advantage to us, and that is we can actually characterize without any prejudice the DNA sequences of organisms, and we can ask questions like, how much of the variation in DNA sequences exists among the people who live in Denmark, as opposed to the difference on the average between Danes and Ewe? I mean, we can ask that question. And that question has some relevance, although it's not completely probative. It has some relevance to asking questions like, do we expect that all the people in Denmark will be smarter than all the people in South Africa? And that's because we believe that genes tell us something about people. So I want to deal with this issue on a quantitative basis. I want to ask the question, putting perception aside and the way in which we learn to distinguish people one from another, what can we say about actual genetic differences between individuals, between groups, within populations, between populations? What do we know about the geography of human biology, and what does that tell us about the concept of race, and how do we have to cope with that when we deal with what is a reality? Race is, look, I want to make it clear, and I tried to make it clear in my title. Race is a reality. It is a social reality, and everybody knows it's a social reality. The issue is, what is the relationship between that social reality, that social allocation of individuals to groups, and anything we can say about their biology? So I speak as a biologist rather than a sociologist, because there's no question about the social reality of race. Now, what I want to do is to go through some evidence about how much difference there is within and between human groups, and then discuss what the processes are that modulate that variation and why it looks the way it probably looks the way it does, and what we might expect even in the future in that respect. So I guess, Ellen, you got to help me here. I can't get on without Ellen. I want to show you a slide which is sort of typical. It's going to take me a minute to explain it, but you're stuck with it. This is a diagram having to do with human ABO blood groups. You all know your ABO blood group. You probably know what group you are, whether you're AB or B or whatever. And this is a so-called trilineal diagram, and it gives the proportion of the gene allele A, the proportion B, and the proportion O at the genic level. So they add up 100%. And it gives a proportion of that in a particular population. And what I have done is plot on this little triangular diagram the location in this kind of funny three-dimensional space, although it really looks like 2 dimensions. It's really got 3 dimensions in it. Frequency of I, frequency of the O allele, the A allele, and the B allele. Plot various human populations. And then I've drawn little circles around clusters. So there's a cluster here, there's a cluster here, there's a cluster here. And the first question I want to ask is, I mean, this is just typical of what we'll see. Is there any geographical or racial meaning to the clusters? They say, if you belong in the same cluster, is it because you're all Europeans or you're all Africans? So these are different populations. And let me give you an example. This cluster here consists of population 2, 8, 10, 13, and 20. Population 2 is an African population. 8 and 13 are Asian populations. 20 are Europeans. So Europeans, Asians, and Africans all clustered together in this one little cluster here. Here's another cluster made of 3, 4, and 5. And number 3 are Africans, and 4 and 5 are Native Americans. So this kind of thing is disturbing already. I'm just trying to give you an example. Genetically disturbing to the notion that there are clear differences between populations. Okay, thanks. This is just an introduction to the general question and the general approach. No, I don't need the next one quite yet. We need to know a few facts about the human species and its genetics, which are relevant. First of all, human beings are immensely variable genetically. The people in this room, one from another, the person next to you differs by about 3 million nucleotides from you. 3 million. Now that's not very many considering that you have 3 billion nucleotides, but nevertheless, there are 3 million nucleotides on the average between any two people in this room. And by the way, that's true whether the person sitting next to you think belongs to the same race as you do or not. There isn't much difference, as it'll turn out. But 3 million nucleotides different. Something like 25% of all genes of known function that produce known enzymes of various kinds are what we call polymorphic in humans. That is to say, there exists more than one form of that gene. Like the ABO blood groups, which there is A, B, and O. So about a quarter of all the genes that anybody's ever looked at are variable in this way, so that some percent of the population has one variant, and another percent of the population has another, and another. So 25% of your genes belong to the variable class. Third, something on the order of 10% of all your genes, you got a different form of it from your mother than from your father. You're what is called a heterozygote. You've got two different allelic forms. So about 10% of your genes are already different from one another in the two copies that you got. And that makes humans pretty typical of species in general. I mean, for fruit flies that I know more about, the numbers are 1/3 of them are polymorphic, and 12% are polymorphic. You got a different one from one parent and the other. But human beings are sort of typical animals in this respect. They're very variable genetically, and every one of you is very different in 10% of your genes, or different in 10% of genes of the gene you got from your mother and your father. Now that's the first thing we have to understand, this huge amount of genetic variation. Now, because there is this huge amount of genetic variation, we are able to ask a question, which is, if you are different from the person sitting next to you because of these variable genes, how much more different are you if you have ancestors from completely different parts of the world than if you have ancestors who came from the same part of the world? If both your ancestors were Swedes, does that mean you're much more similar than if one of your ancestors was a Swede and the other one was Chinese? That's a question we can ask objectively. The second, and one thing we do know, and I want to make this clear from the beginning, we do not know of any gene. No one has ever found a gene. I'm not saying they don't exist, but in all the searching, no one has ever found a gene in which one so-called race has 100% of one form of the gene and some other race has 100% of another form of the gene. There are no single genes that differentiate Africans from Asians, Asians from Europeans, Europeans from Australian Aborigines, and so on. And the second slide I want to show you are the most extremely different genes that we know of between the classical races. And by the way, for a lot of the time when I talk about race, I'm going along with a gag. I.e., Asians are one race, Africans are another race, Europeans are another race, Australian Aborigines are another race, Polynesians are another race. I want to talk a lot about that problem, how you decide, because you can't ask how much difference there is between races until you tell me how you know what a race is and who's in it. I mean, do the people of India belong to the same race that we do? If they don't, then the answer will be different than if they do. So we have that problem. Here are three genes: the Duffy blood group, the rhesus blood group, and the P factor, for which there are greater differences between the classical races. They even have these classical names: Caucasoid, Negroid, and Mongoloid, whatever. What they mean is white, yellow, and black, I guess. What they mean is people from Africa, people from Europe, and people from the mainland of Asia. And you see that there are huge differences in the frequency of the three forms of this gene, the Duffy blood group. Caucasoids only have 3% of FY and a roughly 50-50 numbers of these two, whereas people from Africa are 94% FY. And that's going to turn out to be very useful to us in asking some questions. And only 6% of FYA. But and the Mongoloids are only 9% of this and 90% of this. So you see huge differentiation in this particular gene between these major groups. Okay? That's a maximum. But notice, it is not the case that Africans are 100% of one thing and Mongoloids are 100% of another. There's always overlap, and that's an extreme point I want to make. We don't know of any gene which is race distinguishing. Here are three genes which, on the contrary, show extreme similarity in frequencies of the variant types. The Auberger factor, 62 to 38, 65 to 35. I don't have the data for Asians. XG, 2/3 to 1/3, 55 to 45, 55 to 40, and so on. So these are, I put these up to give you the outside limits of what we know. Some genes you can't distinguish by frequency at all between major groups, but there are a few genes in which there are big differences. But that's about all you can say. But I do want to emphasize again, I've said it 3 times and I'm going to say it again. We do not know of any gene which, if you've got it, you're certainly, that distinguishes you 100% from some other so-called racial group. Okay, now we could dispense with that. Now what I want to do is to ask the question which I began with: how much variation between individuals lies within local populations, how much of it lies between populations belonging to the same, what we call classical race, and how much of it comes between races. Now, to ask that question, you have to define these races to begin with. I can't ask how much genetic difference is there between races until I decide who's in what race. And that turns out to be not so easy. For example, are the Turks Asians or Europeans? Well, you see, they speak a Central Asian language, but they look like Europeans to me. Are the Urdu and Hindi-speaking people of the Indian subcontinent, are they belong to the Caucasians, or should they have their own group, or are they Asians? What about the people of the Pacific, the islanders of the Pacific, and so on? Each one presents certain contrasts linguistically and physically. The Finns are a real pain in the neck because nobody could look more washed out European than a Finn, but they, alas, speak a Turkic language, a language they got from Central Asia, so maybe we ought to throw them in with the Chinese. You see the problem, that the definition depends in part on those a priori perceptions you already have of what race are, and in part on knowledge about linguistics, and in part on knowledge about movements of people. I'm going to show you the result of a study, the first one that I know of that was done about this, in which racial decisions were made, and essentially the world was divided up into yellows, blacks, browns, reds, and whites, with a few extras. The people of Southeast Asia were put in a separate race. The Oceanians of the Pacific were put in a separate race. I mean, something had to be done, so that was what was done. We have less problem deciding whether people belong in the same national group or local group within races, local population, because we have linguistic definitions. I mean, there are some people who speak Italian, some Irish, some English, some French, and each one of those linguistic groups is considered. We have Ewe and Kikuyu and so on. Those are put in separate groups. And now we can ask the question, how much of the known genetic variation, of which there's a lot, falls between two individuals, both of whom came from the Ile-de-France? How much of it falls between French people, Italians, Germans, Swedes, and so on? And then how much of it is between Europeans on the one hand and Africans, sub-Saharan Africans on the other? So we can break down the variation to within local populations, between populations belonging to the same so-called race, and between races. And when that study was done, the result looked like the next slide. At the time this study was done, worldwide information existed. I mean, this study had to depend on the literature of science. Worldwide information existed for these bunch of genes. They're a mixture of human blood groups and various enzyme proteins. We needn't concern ourselves with what they are. And then the question was asked, of all the variation within the human species for a particular gene, like the HP gene, how much of it, what proportion of that variation occurs within local populations, within Zulu, within Italians, within Han Chinese, and so on? How much of it is between populations, between Japanese and Chinese, between Ewe and Kikuyu, between Toba and Bloods, between Sioux and Utes, and so on? And the answer, for example, for HP was that 89% occurred within various populations, 5% occurred within, between populations within what we would call a race, and only 5.5% occurred between black, white, yellow, brown, red, and the others. All right? Is this clear to people what's being done here? The total variation is being divided up in these three categories. And if you do that for all the cases, and I won't go through all these, they're just a bunch of numbers, the grand average, which you may not be able to see in the back of the room, is that 85.4% of all human genetic variation then known by these genetic techniques, 85.4% occurs among individuals belonging to the same linguistic local group on the average overall groups, within the Utes, within the English, within the Icelanders, within the Zulu, and so on. Is that clear? 85%. A further 8% in this study fell between linguistic groups within what we would call a race, between Italians, French, Germans, between Zulu and Ewe and Kikuyu, and only 6% fell between these major races. Now, you do appreciate that although this number here doesn't depend on how you define races, the split between these two does depend on how you define races. Which group you put in which race and which group you don't. So that's what, but 85% of that variation falls within. Now this study comes from the Pleistocene of science. I mean, it was done when we knew nothing about DNA sequences and so on. And it's entirely conceivable that when the thing is updated and people actually look at DNA sequences, that the answer will be quite different. I want to show you the result of the studies of Dr. Barbujani on DNA sequences in humans, which are not identified by any particular genes. We don't know what they do. They're just chunks of DNA plunked for various reasons out of the human genome. A huge number of numbers. Ignore. I mean, forget the details. Just believe what I tell you. Here's the name of all of these little bits and pieces of DNA, which are recognized by the techniques of DNA hybridization. Forget about nobody knows what they do anyway. They don't do anything. They're just genetic variation. And here is his list of the percent of the variation for these different ones that fall within groups. And these are not the same as the genes I just showed you. The total answer comes out to be 84.5%. That's pretty close. In fact, that's closer than any scientist is entitled to expect. Remember, the previous result was 85.4. Barbajani's result is 84.5. He got the two last numbers confused. But when he then asked how much is within he called it within continents, and that meant that he had a particular way of dividing populations belonging to the same or different races, which was different from the previous study. He only got 4% between groups within a race and 11.7, about 12% between races. So his amount between races was about twice as much as the previous study. But the within group variation, as opposed to between group variation, was identical with the previous study. 85% within and 15% between. And depending on how you decide who goes in what race, you get more or less these two categories. In fact, a number of such studies have been done, and let me show you all of them. That's the next slide. The number of studies being 4. It's pretty remarkable. It really is. I've never seen a scientific result as clear as this, a numerical scientific result as clear as this. Here are the 4 studies. The first one based on proteins is the one I showed you originally. There's another one by Barry Latterton, and then one on proteins, and then DNA study. And look at that, 85.4, 83.8, 86, but the point is made. Thank you very much. That 85% of the variation is already present in all the people who are like us. And only 15% are someplace else, and some fraction of that, between 3% and 8%, is people who we think are like us anyway. I mean, sure, they might be Swedes and we're Danes, but we don't make that distinction. Or between French and Irish. And only something on the order of 6 to 10% lies between them, the ones who all look alike, and us. Now, that's a fact of life, and that's a fact with which one has to cope, that there is a strong contradiction or disagreement between our perception of a lot of variation with us and no variation in them, with the observation that they're just as variable as we are, and the differences between us and them are pretty small on the average genetically. I want to depart from these results for a moment to say that doesn't mean that there are no genes which are found in some mutations which are found in high frequency in some groups and not in others. We all know that Tay-Sachs disease is in very high frequency among Ashkenazi Jews and is essentially missing in many other groups. That's a special mutation which has risen in frequency for some reason we don't understand. We have guesses about it, but we don't really know. Or the famous case of sickle cell anemia, which is essentially unknown in Finland, but is very common in Mediterranean groups, not just African groups, by the way, but Mediterranean and East Indian groups as well. Various forms of abnormal hemoglobin are spread through the Mediterranean and West African groups. So it doesn't mean that because there's 85% variation within, that you can't find occasional genes, which really do, as I showed you in the very first slide, or second slide, genes which are highly differentiated between groups. But they're not typical. And we don't need all these fancy data to know that, because we identify people of other races by things that are genetic. Skin pigment differences are genetic. What I'm trying to say is that the differences between those groups are only skin deep, if I can put it that way. And therefore, any claim, and this is the important point, any claim that because there are patent differences in skin color or height or hair form or eye shape or something between groups in different parts of the world, that implies that there are likely to be differences in genes that matter to any sensible person, genes that contribute to our ability to solve mathematical equations or to be nice to other people or something like that, if such genes exist. that carryover cannot be made, because the genes that are very different are the exception rather than the rule. That doesn't prove, and I have to say, to avoid a question that someone will ask me, that doesn't prove that there isn't a gene someplace, nobody's ever found it, that might influence your charitable instincts, and that maybe people in Africa have a much higher frequency of that gene than people in England. That could be, but nobody's ever found it. And there's no reason to think that such things exist. So those are the facts about human genetic variation. That tremendous variation, almost all of it, within any local group. And the question we have to ask is, how does that come to be in the face of the fact that there are some obvious physical differences between people in different parts of the world? Skin color, for example, hair form, and so on. And that means we have to ask about the forces that operate on genetic differences between and within groups. The first thing I want to show you is that most of the extreme differences that we know of, where there's a very low frequency of one form of a gene in one group and a very high frequency of another form in another group, most of them are between small isolated populations, hunters and gatherers, or people living in jungle regions or something like that. They're not between the main body of West Africans and the main body of Europeans. That's not true for everything, but this is a list, and we're not going to go down the list. But notice that for example, for this gene, phosphoglucomutase, the lowest frequency of that gene is known among Habana Jews, and the highest, which is a very small group, and the highest frequency among the Yanomami Indians. Take another one. Here's NS. This is a blood group type and secretor type. 5% is the extreme low value in the Navajo, and 65% in Palauans. 0 in Luo, 96% in Papuans. Ainu appear, Basques appear, Blood Indians appear, Chenchu, Eskimo, Dayaks, people of the Yucatan, people on Tristan da Cunha, and so on. Over and over again, the names of these groups, which are at one extreme or another of the genetic variation, are names of small groups living in out-of-the-way places, fairly isolated from other groups. And that's a very important observation, that most of the genetic differences are differences at the extreme. If you think of all the frequencies of genes as sort of being clustered in a space, then the ones on the outside of the ball, the ones that are oddball, are these very small populations isolated from one another. And we have to understand that. It's not always true, you can find exceptions here, but it is the general rule. And the question is, why is that? How come my list contains all these oddball in the sense of small groups outside of our experience? Part of the reason, probably an important part of the reason, we don't know, by the way, we don't know the answer, because we don't know, for example, how natural selection might operate on these genes to make Papuans have one form and Luo have another form. But probably the answer has to do with the fact that they are very small in numbers. And when populations are very small in numbers, then they differentiate from one another in the kinds of genes they have by sheer chance. Let me show you one of the most extreme cases I know. This is really a very striking case. This is a genetic type that people use in forensic uses of DNA. They say, oh, Your Honor, the probability that the person on trial did not commit the crime is 1 in 4,327,256, because we know that because we looked at his DNA. This is one of those DNA differences that are used for that. And I want to call your attention to the frequency distribution of the 9 different kinds known in 2 populations. The Karatania, which are 97% number 1 and 3% number 6, and don't have any of the others. as compared to the Surui, who have 56% of 1 and 14% of 2 and 14% of 7, blah, 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 blah. Who are the Karatani and the Surui? They are two Brazilian Indian forest-dwelling groups living within 500 miles of each other. And they are as extremely different as you can get with respect to this gene. How did that happen? They're even linguistically separated from one another. So somehow, in the history of the evolution of these groups, they have become extraordinarily divergent. It'd be hard to make the case, I think, that natural selection favored number 1 in the Karatani and and something else in the Surui. I suppose it's possible. But the answer is almost certainly a consequence of the small size of the breeding group. And the way it works is as follows. You have a very small number of people who represent the breeding population. Some of those people have no children. Some have 1, some have 2, some have 3. Moreover, if I have 2 different forms of a gene, half of my sperm have one form and half of my have the other. And if I only have 1 kid, that kid will have one or the other, but it can't have both of them. So the result of that is that every generation, there's a kind of sampling process, like tossing a coin by chance. And that means if you start out a population with 50-50 of 2 forms, the next generation made up of 27 people, or 420, or even 1,000, will not have exactly 50-50. They may be 48 to 52, or even 45 to 55. Well, what about the generation after that? Well, they don't tend to go back. There's no law of averages, because they started out with 45% of one type and 55% of the other. So the next generation makes a sample from that. And it's what's known in our field as a drunkard's walk. That is to say, what happens is if the frequency of the thing goes from 0 over there to 1 over there, then the frequency of the thing every generation takes random steps back and forth like this. And if you wait long enough, it falls off the platform on one side or the other. That is to say, everybody has one kind or the other. But some groups will have one kind and other drunkards will fall over there. And that's what's known as the process of random genetic drift. And all populations and all genes are subject to this phenomenon, but a very small population is obviously much more subject to it than a very big population. So we expect, indeed, that very small populations will tend to be outliers. They will be more drunken, if you like, in this random walk, and will be closer to one of the edge points than others. And that is a very important factor in the differentiation of groups. So even though it's true that a fair amount of genetic variation occurs between populations and between major groups, that is not the same as saying that those differences arose for functional and natural selective reasons, because this population ought to have that and the other population ought to have that. A good part of that variation between groups is sheer chance. And I must emphasize that, because you don't want to make too much of the variation of the differences that do exist. The other feature which we have to take into account, the very important feature we have to take into account in trying to understand the origins of variations, have to do with the fact that human populations have been migrating, slave-taking, raping, carrying off other populations, presumably in prehistoric time and certainly in all historical time. Let me say a brief word about the Icelanders. Some of you have heard that some people in Iceland claim that Icelanders are more genetically homogeneous than anybody else in the world. And why is that? Because Iceland was founded by a few hardy Vikings, and after that all the breeding occurred within Iceland and no foreign genes came in, and therefore Iceland, everybody is related to everybody, and therefore that would be very good for, I don't know, some medical purpose that I can't fathom. But the reason I haven't tried to fathom it is because it happens to be untrue. If you look at these data about genetic variation of all these kinds, for Icelanders, they turn out to be, roughly speaking, as variable as Norwegians, English, Scottish, Danes, and so on. And indeed, they fall right down in the middle of all Europeans. I mean, they're far from being the most homogeneous of all Europeans. They're sort of in the middle someplace. They're nothing special. And why is that? Because if you and as every geneticist, human geneticist should do, if you read the sagas, the Icelandic sagas, you will discover that the Icelanders made a living exactly, the Icelandic Vikings made a living exactly the way the classical Greeks made the living. Namely, they were farmers half the year, and the other half the year they were pirates. They got on their boats and they went off raiding. And when you raided, you just didn't take money and things, you took girls too. And there were slaves in Iceland. Those slaves came from Russia, they came from Scotland, they came from all over the North Sea. There was a tremendous amount of slave taking and a tremendous amount of the sort of thing you expect from pirates. And the consequence of that is that the Icelandic population is as heterogeneous as genetically heterogeneous as any population in Europe. Indeed, you can trace that. I should take a cultural detour here. I do urge you, those of you who are interested in the subject, to read the sagas. They're a real eye-opener. If you look at place names around the northern border of Scotland, the northern one-third of the Scottish coast, you will discover a lot of place names that have the word Ness in them, like Loch Ness and Inverness and so on. Ness is the Icelandic word for cape, and it's the capes on which these pirates landed and set up little settlements. So northern Scotland is as Icelandic as it is anything else. And it's extremely important to understand, I tell this story in some detail, because this is the story of human movement and mating and so on. A lot of moving around, a lot of taking of captives, of slaves, of rape, of all that kind of, and it's gone on all over the world. I mean, you might like to think that Europeans invented slavery, but they didn't. Now, I want to show you, for example, the effect of cross-group mating in the United States. We have a fairly good idea from this FY blood group that I showed you, which is highly differentiated between Africans and Europeans, of how much mating has occurred between Africans in North America brought over as slaves and their European masters, or more recently between Africans in urban areas and Europeans in urban areas. There's a history of mating that's occurred between these two groups, and we have a fairly good notion of how much that is. Our estimate, based on this gene that happens to be highly differentiated between Africans and Europeans, is that among people who classify themselves as Afro-Americans, or blacks, at that time they were classified as blacks, the proportion of their European ancestry was 19%. Among those who lived in Detroit, it was 26%. Among those in Oakland, California, it was 22%. Among the people in Charleston, South Carolina, it was only 4%. And in Evans and Bullock counties in Georgia, rural counties, it was 11%. So that gives you some notion of how much intermixture has gone on. Various people who are classified as Afro-American have various amounts of European and American Indian ancestry, but on the average, in the larger cities of the United States, people have something like 20 to 25% European ancestry. And that's only been going on in large amount, presumably since the beginning of the 19th century, or perhaps a little earlier. So the rate of infiltration of genes from one group into another, where the groups themselves still maintain some kind of arbitrary racial classification, and that's important. Look, this is an underestimate, because it's only the people who report themselves as being African American. How about all the people in this room who don't report themselves as being African American, but like Pushkin, have an African grandfather or great grandfather? Pushkin was a great. Alexander Pushkin's great grandfather was a famous general, Russian general, who was in fact an African, who was a kind of Russian Othello. He became a very important person in the Russian military. Pushkin would not have reported himself as black, but 1/8 of his genes came from Africa. And that's important to understand that. Okay, well, you don't have to see the numbers. So you have fusion of populations. But you also have, on the other face of it, a tremendous amount of local marriages and staying where you are. And you also have the effect of migrations and of conquests, like the Icelanders, which leave their genetic trace in places where they came in. And we could look at the next picture, that first map, which is supposed to be of the British Isles. It is. You will notice that migration also occurs by continental drift, because in the north of the British Isles is Kyushu. I don't know how Kyushu got just to the north of Scotland, but there it is. Please ignore it. You'll see Kyushu on another slide. This is a map of the frequencies of the blood group A, ordinary blood group A, in different parts of England and Scotland. And I don't know if you can see it at the back of the room, but the average frequency in northern Scotland is 31% of type A. It gets down to be 35%, 39%, down to greater and greater. And just off the east coast of England, it is 46%. Now, England, as you know, is one of the most, as they used to say, bastardized countries in the world. It is a consequence of invasions from Denmark and Saxony, from France, from the north, from the Vikings and so on. And what has happened is that where the invaders land, they leave their genes quite locally. And even though those invaders no longer arrived after the 11th century, the last time there were serious invasions of England was the 11th century, their genes have stayed around. And if you look, this part of England, which is called, I don't know how you pronounce it in English, Danelaw or Danelaw, which has a lot of Danish place names and so on, has Danish blood group frequencies. And this part has Pictish and Gaelic blood group frequencies. And Ireland, which is not shown in here, is quite different. However, you notice 37.6 right here? That's like Ireland. Why is that? Because that's where Liverpool is. And that's where large numbers of Irish immigrants arrive still into Britain. So, despite the fact, and I was talking to Bonnie Slatkin about this, I was puzzled by it, but he, I think, gave me the right answer. Despite the fact that England has, since the 17th century, since the Acts of Enclosure, the first Acts of Enclosure, had a huge amount of migration of people into cities from the countryside. The ones that are left behind, see, Liverpool does influence this, but London apparently not much. The ones that are left behind in the country are the descendants of those invaders, or the Picts who were pushed north, or the Danes who came in, and so on and so forth. So still to this day, Britain shows the history of invasions of more than 1,000 years ago. Now, that's not only true of Britain. The other extremely industrialized country for which this is true is Japan. There's Hokkaido, Honshu, Shikoku, and Kyushu, and here's the Korean Peninsula. And this is the frequency of the blood group A in Japan, which is about 24% in Hokkaido, among the Ainu and Japanese in Hokkaido, and reaches a maximum of more than 30% here. These decline in frequencies is maintained, despite the fact that Japan is highly industrialized and a great deal of movement, because the people who stay behind are the but this is much more ancient in some ways and more recent in others than the English situation. I call your attention to this cluster here across the Straits of Tsushima from Korea, which has this gene frequency, which is like the Korean gene frequency. People living across the Straits of Tsushima from Korea, in Kyushu and southern Honshu, have gene frequencies like the Koreans. Why is that? Because there were repeated invasions of the Japanese archipelago from Korea over and over again by the Chinese, by the mainland Chinese. And the last of those invasions occurred in the, somebody's going to tell me I'm wrong about this, but I'm going to say the 15th century. And that last attempted invasion was in the 15th century, but it didn't work. Why? Because the invasion fleet, which was leaving Korea to arrive in Japan, was blown away by a huge tropical storm, which was called the Wind of the Gods, which in Japanese is kamikaze. So the first famous kamikaze got rid of that, and the Chinese never tried it again. Nevertheless, since the 15th century, that differentiation has remained, and is probably the long time history of Japan, with northern Aborigines here and mainland Asians here fusing together to form the modern Japanese population, and the decline still shows. So, what I'm trying to emphasize to you is if you want to understand the genetic differentiation between people, you have to understand that a constant feature of it has been invasions from one place to another, cross-mating, and the world is a kind of hodgepodge made of that. And the last picture I'm going to show is a very abstract picture which I cannot possibly explain to you correctly. It's an attempt to summarize everything we know about gene frequency differences all in one number. It's called a principal component, and maybe a few of you like Leo Goodman know what that means, but I'm not going to try to explain it. It's a way of combining the numbers from all the different genes in an optimal way. And what this shows is the value, roughly speaking, of that principal component of human variation in Africa, Europe, coming across Europe this way, getting smaller and smaller and smaller, and being smallest in Asia. That's the so-called first principal component. And what it reveals is the big picture of migration in the Eastern Hemisphere. Well, in the world, in fact. You had a northward spread from Africa into Europe, so the European gene frequencies in their principal component are most like Africa. I know that'll be very alarming to some Europeans, but there it is. The Slavs are somewhat less Africanized, and then when you get into Central Asia, it changes somewhat, and then you get into the steppes. When you get into Central Asia, it moves again. Australian Aborigines are off by themselves, and then these Asians, these Siberians, moved into the New World and moved south, and so on. This is a picture of the general migration of people from prehistoric times, perhaps from the origin of humans in Africa. So if you want to understand, and now you have to tell me, where are the racial boundaries? Well, if I use principal components, then of course all the Africans and their English and French masters belong to one race. The people of Central Europe belong to another, and so on and so forth, which doesn't, of course, correspond to what you ordinarily think. So, my final point is that human genetic variation, we can get rid of that last slide, Ellen. The human genetic variation is the consequence of a long history of migration, of cross-mating, of piracy, of slave-taking. You know, by the way, just make a parenthetical remark, if you read Henry M. Stanley's journal of how he found Livingston in Africa, you find that as he moved across from the coast to Lake Victoria, he passed through one town. He didn't hack his way through any jungles. He walked on a road, and that road passed through a lot of towns. And the chief in those towns was always called the Sheikh, because of course the Arabs had been there long since, and they had left behind not only culture but genes as well. East Africa is very much Arabized, at least in Henry M. Stanley's time. So the picture you have to have is of a mobile species moving from its origin throughout the world, occupying the world, and in the process, by mercantile movement, by slave taking and so on, mixing things up, leaving behind some variation whose origin we don't really understand. I mean, I don't know why people in West Africa have dark skins and people in Finland have light skins. Don't believe the stories, and I want to end this, don't believe the stories that, well, it's because if you're in the far north, you don't get much UV. If you don't get enough UV, you'll have rickets, so it's better to have the lightest possible skin so you get as much ultraviolet as possible. Whereas if you live in darkest Africa, why, you might get skin cancer if you didn't filter out all that sunlight. So natural selection has made your skin dark. Those stories don't work for a variety of reasons. One is because even the most avid sun lover of the Los Angeles beaches, who finally gets skin cancer from constantly being irradiated, generally gets that skin cancer after reproductive years. It's not a serious issue in reproductive rates. And as far as UV is concerned in the far north, it's not clear to me that if some people got rickets that had any effect on their reproductive rate at all. The most fertile mouse I ever worked with when I used to work with mice was a so-called paralytic mouse, like a male who could barely get himself around. So those stories are easy to tell, but we have no evidence about them. My best guess is that the differences in skin color, hair form, eye shape, and so on are a consequence of Darwin's notion, a notion that Darwin had, and that of so-called sexual selection. That for one accidental historical reason or another, the person who was darkest in skin in your place seemed most powerful and most attractive and became the model for beauty, whereas someplace else it was some other oddball morphological feature. And the consequence is that there is, by reduplication of that, a build-up of differentiation based on who wants to have mate with whom. Now that's just a guess, I don't know. But none of these natural selection stories work. And I think you should abolish them from your notions. We do not know why the skin-deep, superficial, minority differences in genes that do exist between major geographical regions exist. We don't even know where the genes for skin color are. Nobody's ever found them. I mean, they're there somewhere, but we don't know. Okay, so let me then end by saying that although race is unquestionably a reality, a social reality in every place in the world, it is not a very good biological reality. It doesn't make sense biologically. It's not the way a systematist would want to divide up the species, if that seems sensible. It is rather an excuse for a social reality and an attempt to prove that that social reality must also correspond to deep and important differences, some of which are appearing on the surface, but most of which are inside and important. And the evidence is against that. And so I think you need to reject the notion that race is a sensible biological concept for humans. Thank you. And again, I apologize for all the numbers. If there are questions, Ellen has said that you must come up to this microphone and ask the question.
So what is the latest status of out of Africa theory and multi-regional hypothesis? Which one is the latest has more evidence?
Status of the out of Africa theory. Well, there's a general consensus that that's right, and this components analysis that I showed you underpins that. So I'd say that's right. It's a big difference between saying that's the general consensus of people who work in the field and saying that it's somehow proven as the night the day. That's another issue. But that's the general status, yes. Since you've asked me about out of Africa, I should make a remark. I believe that human ancestors originally differentiating came out of Africa, but I haven't the faintest idea what they looked like. Look, that's very important. They may have come out of Africa, but that doesn't say they were black. For all I know, they look like Arabs, or they look like something we've never seen. I mean, we don't have the faintest idea what they look like. Because if the theory of sexual selection is right, this differentiation of skin color and hair form and so on is something that occurred subsequently or during the process and tells us nothing about what our Aboriginal ancestors look like. But they did apparently come out of Africa, yes.
No, one more. I was watching Journey of Man by Dr. Spencer Wells.
Yeah.
So according to him, you know, there is this group of Kalahari Bushmen who are supposed to be the original group. So what do you think of that? What's your take on that?
Well, I don't have a professional opinion on that. I should confess that Spencer Wells was my graduate student, and therefore I'm not perhaps capable of giving an objective opinion. I'll say nothing more than that. Don't get the wrong idea. But the Kalahari people are a special case, or a kind of special case, which we have to be very cautious of. Most of the people, like the Kalahari, are people who apparently have been pushed out by more powerful groups from a different sort of life and marginalized and live a marginal existence. That was almost certainly true for the people of Patagonia, of the extreme south around Cape Horn, of the Kalahari, indeed of the Berbers, the desert dwelling pastoral people of the Near East, who, if one believes Ibn Khaldun, were repeatedly extruded and then conquered, and then extruded and conquered. So I'm rather loath to come to conclusions about evolution from groups who have been somewhat recently, we don't know how recently, were originally part of another population and then shoved out in small numbers. I think it's dangerous to make too many conclusions from that. Okay.
Thank you.
In your final slide, the upper map was principal component 1 that is consistent with the out of Africa hypothesis. But the lower map, I'm wondering if that's principal component 2.
It is.
And I'm wondering that because there was a line across Africa at the Sahara, there's a line across Eurasia at the Urals, and that would seem to suggest that the primary signal in human genetics is out of Africa and the colonization of the planet. But the next strongest signal is the regional differentiation.
Absolutely. I mean, you're quite right about that. For this particular purpose, I can't go into the difference between the first and the second principal component. But what you say, I think people should listen to. Yes.
All right.
You may be familiar with the Affymetrix gene chip platform. Are you familiar with any new studies that look at gene expression analysis on top of just the gene differentiation?
No, I'm not. I'm sorry. I mean, I'm familiar with the Affymetrix gene chip, but perhaps you want to say something about it.
No, do you feel, knowing about that technology, do you think that may reveal more information about the subject?
Well, the trouble with gene expression is that expression patterns are embedded in a network of signaling, of expression signaling, which would be very difficult to interpret in the way we need to. That is to say, we might have a different expression pattern in one group than another because one gene is being expressed differently, and that's having a downstream effect on the expression of others. So I'm not saying that expression patterns will not be of any interest, but I think their interpretation is subject to the serious complexity of the patterns of expression induction, and I don't know exactly how to interpret them is the problem. For example, I don't know, somebody can tell us because they could look, what the effect on gene expression patterns of all kinds is of people who have, say, sickle cell anemia as opposed to not sickle cell anemia. Does that have consequences in other parts of the gene expression pattern? I don't know the answer. You could find out. But I think one has to do that. One has to, because of the epistatic interactions between gene expression patterns. That's the best I can say.
Hi, I thought the sexual selection story that you gave at the end was very interesting. I had never heard that before with people. And I was wondering what you think would be an ideal test to test the sexual selection story versus a non-sexual natural selection story, such as the one that you mentioned about vitamin D and cancer, short of time travel?
I don't know the answer to that question. Monty, have you got an answer to that? How I could distinguish sexual selection from what we usually call natural selection? It doesn't seem obvious to me because the difference is not a statistical or mechanical difference. It's a difference in causation, which has the same influence on the fact that some types have more offspring than others. And the various statistical tests one does doesn't ask why do some types have more offspring than others. It only presents evidence that some types do have more offspring than others. The differentiation between natural selection and sexual selection is in the engineering story you tell. And that's a physiological story which is not revealed by patterns of gene frequency. So I guess the reason that even Monty can't answer it is because it doesn't have an answer. No, I'm serious about that. I mean, you have to understand that sexual selection does not differ in its dynamics or kinetics from other kinds of selection. It's just a different kind of causal story. It still winds up that some people have a lot more offspring than others, and certain genotypes have more offspring than others.
Two questions. First, what is your perspective on hybrid vigor? And secondly, what do you think about this whole idea of the surface meaning does not have this deeper meaning, and what are the implications for...
I'm sorry, what was the second question?
The whole idea about these surface differences really don't have these deeper meanings that we sometimes in the lay public apply to them. And how do you speculate your information? What effect do you think it will have on the lay public, which sometimes want to perpetuate these notion of racial prejudice and so forth?
Well, the answer to the first one, as far as hybrid vigor is concerned, there's no evidence of hybrid vigor. Indeed, there's no evidence of hybrid vigor in corn. I mean, I could give a whole lecture on the nonsense about hybrid vigor in corn. The hybridization in corn is a gimmick to guarantee property rights to seed companies. We could produce corn as productive as hybrid corn by mass selection. That's well known. That's not a problem. So to try to carry over the claim of hybrid vigor from corn to people, if that's what you're asking, whether people who are the result of matings between distant groups will somehow be better, we have no proof it couldn't exist, but we have no evidence for it. Now, one thing that does happen is if you mate between people who have rather as differentiated gene groups as possible, you may cover up certain deleterious recessive genes. That may happen. But I don't think that's what you're really asking. And one more, no, let me finish my answer to her. As far as what effect this has on the attitudes of people toward superiority of one race or another, it's not clear it has any effect because, as I said, the fact that 85% of the variation is within a local group and so little of it between doesn't prove that the genes that really matter are highly differentiated between groups. I could always say, yeah, but what about that small percent? They're the one, you haven't told me about the genes for IQ, the genes for charity, and if I want for some ideological reason to claim that there are those, I haven't proved they don't exist. So I think data like these in large part predispose one toward an understanding of the situation, but if you're a hardcore racist, they're not going to have any effect at all.